Hey guys, welcome to our video surveillance masterclass. Today we'll talk about the basic concepts of a video surveillance system. This content is a foundation if you really want to start your business or work in the video surveillance area, to really understand all the key components in the video surveillance system. I am Marcelo from Security Systems Center, a channel that brings you valuable information about video surveillance, access control and intrusion. In this video surveillance masterclass, we'll talk about the video system component: capture, recording, monitoring and playback. This is a class about the theoretical concepts that you can apply to any video systems from any manufacturer. This core content is very important to build a foundation in the video surveillance systems. At the end of this class, you'll be able to tell the different capture devices, recorders and monitoring systems that are used in the video installations. Even though this class is for beginners, it's a good opportunity to get the full system scenario view and see opportunities in the current or future installations. So let's start. Okay, in this introduction class, I will talk about the key components on the video surveillance system. Initially, we'll talk about the capture devices, so our cameras, recording devices, our DVRs, NVRs, and etc. Monitoring, how we do this important piece on the system, and the playback, another key component as well. Okay, so let's jump to our capture. So when we say capture devices, we are talking about video and audio capture from the scenes that we are planning to monitor or to keep it safe, to have eyes on the installation. So initially we'll talk about video, and we'll talk about the different types of cameras that we have in the market to solve or to fulfill the project needs in each type of scenario. Okay, initially we have the box camera. The box camera, it's a relative old camera. It's like some legacy device that we may see in some installations. So basically we have it's really like a box, like a square, and inside we have all the recording mechanism in this square here, in this box. And we have this front part here, the sensor exposed, the sensor that will capture this image and transform it digitally to be transmitted to the NVR. So in this type of camera, these box cameras, we have the option to add lens, so we can attach lens, can be fixed lens, can be MFZ lens, so multifocal lens that you can zoom in a specific level. When we have the motorized focus zoom as well, so this type of lens has normally a cable here that you connect in the side of this camera to control the lens. And in the back here we have the cables. If it's like an analog camera, you know, the coax cable, the auxiliary power supply cable. Sometimes we have alarm input, alarm output, or the Ethernet cable if it's an IP camera. Okay. This type of camera, normally when installed indoors, we have a bracket here, like something like that will be installed in the wall or in the ceiling. So this is a very traditional type of camera that we see in the cartoons or anything like that represent a CCTV camera. This camera normally, if it's installed outdoors, we have an enclosure that is like a big structure, a metal structure with a plate here in the top, and then with a glass here in the front, and with the bracket that will protect the camera from rain and sun, etc. So this is a very old type of camera. Normally we don't see these in new installations, but we may see this type of cameras or even need to replace this type of cameras. Okay. The next camera that is similar to the box one, that is the bullet camera. Bullet. So the bullet camera, basically it comes with this part that you fix in the wall or in the ceiling, and it's very similar to the box camera with the lens already embedded in this structure, and normally it's already created with a material that will be able to handle rain and sun, etc., and has some classifications like IP66, IP67, as we saw in other classes. Okay, I have one here to show to you. This is a type of a bullet camera. So in this part we will install in the wall or in the ceiling. We have a flexibility to adjust the angle, and then we can adjust the correct position. Okay, then we have the lens here, and we have the cables in the other part. Okay, so this is the bullet camera. The next one is a very traditional one. It's the dome camera. Dome camera because it's a rounded camera with a dome that it's made from acrylic or in other materials, and especially for when we have like a IK10 rating, the one that will be able to support a hammer trying to smash this camera, the anti-vandalism camera. It will be made from stronger materials. So this dome camera, we have this plastic dome here, and the lens and all the sensor and all the mechanisms inside here. So dome camera is something like this. So we have this plastic bubble and the lens here and all the circuits inside, and we have all the cables. Okay. In the dome part we have another subtype, which is microdome. A microdome, it's basically the same thing as a dome, but we have a very tiny dome in a specific area here. So it's like a round structure, a round base, and a small bubble in one of the sides, and looks like this. So you have this structure here protected, and just this tiny part that we have the dome and the lens that you can adjust angle depending if you're installing in the ceiling, in the wall, or etc. Okay. The next one is called bow cameras or turret, depending on the region or who calls it. But basically, it's really a bow structure, and then we have an external part that keeps this round structure fixed, so you can adjust here the angle, and then you can screw here the fixing screw to make everything tied and fixed in the correct position. Okay, so one of the type of bow camera. So here, I'm not sure if it's very have this screw here, but this is like a round, like really a bow structure, and we have this part that will make it fixed static in the correct position. This is the ball camera. Ball camera. After this ball camera, we'll talk about a very let's put like this, and, something like that. Yeah, it's not very good drawing, but it's called the PTZ, the PTZ camera. So the PTZ camera is the cameras that you see moving around in any direction and doing the zoom and etc. So this type of cameras normally is very expensive because we have motors that will be able to move around this heavy structure, you know, having the pan, the movement pan, this horizontal one, the tilt, the vertical one, and the zoom. So we have the zoom, the lens doing the zooming action as well. So a PTZ looks like this. So this is the PTZ. Here it's moving in the pan axis. Here's in the tilt. So do the tilt, and then the zoom inside it will do the zoom in the lens. Normally it's installed like this, right? So this is another type of camera. This is normally installed in areas that we have an actual and active monitoring happening. So the monitoring staff can try to, to look or find suspicious activities and follow targets and to really, it's more like an active way to monitor and not just leave to a specific scene. This type of camera has several type of tasks or working modes. For example, it can do auto scan, can stay static, can stay static, and if an object appears or if a person appears, it will automatically zoom in the person, it will follow until it leaves the scene. So we have several different type of modes in this type of camera. Of course, it depends from the manufacturer and the model as well. Okay, and then we have the fisheye. Fisheye camera, normally it's around the structure here as well, a little dome just like the micro dome camera. Fisheye. And we have the sensor here in the middle. This is the fisheye camera. So we have this round structure, the little dome here, and the lens inside of this dome. So this fisheye camera, we have the 360 view, the 360 degrees view, and it will, depending on the software that you have this camera, you'll be able to dewarp this image and act like a PTZ, like a ePTZ, a digital PTZ. So 360 degrees. And this type of cameras is very useful to install in a specific height, and you can cover a very good amount of the scene that you need to monitor. And this camera is used when we need to cover a good area, like a hall or some entrance, or like a room that you can cover all the angles, and you can record everything at the same time, because it will be the difference from the PTZ. When you have the PTZ, you can move around the PTZ, but you're losing the information of your scene in the region that you're not focusing in that moment. So in the fisheye, you are recording the 360 degrees view at the same time. But the downside is we have the sensor here, and the sensor has a specific resolution, and you are dividing all the resolution in this 360 degrees view, and this leave us with specific areas on this image with low resolution, or with a lower resolution that is supposed to be as you buy a camera like hitting like a 5 megapixel or 8 megapixel camera. You will not have an 8 megapixel like a square that we have normally in the other sensors, because as we are creating like a 360 degrees view and merging in a like a square format or like a round format, we will lose in the edges a little bit of resolution. Okay, so if you install like this camera in the ceiling, you have this camera here, for example, and here's the ground, here's the ceiling. So if you have a person here, to be in the highest resolution possible for the camera, but if you have a person like here, these area start to have a very lower resolution, and this other as well, you know. So if you need to get more information, face recognition, license plate recognition or something like that, not a LPR of course, but you need to recognize a license plate by looking on it, it will be very difficult in these areas of the fisheye. And this situation can be and we have a specific type of camera that can handle this type of situations, that you can have the full resolution per area that you are looking for, which is the multi-sensor it varies, you know. The structure can be like a big bullet with two screens, with two glasses, can be like a round one with a camera on each side. It varies, but this will be the multi-sensor camera. So this multi-sensor camera means that you have more than one image sensor capturing the scene. And this is very helpful because, for example, let's assume the PTZ. We have some manufacturers that created a PTZ. So we have it in the base here in the lower area, the PTZ that actually do the same, you know, PTZ commands that we know. And in the top here, we have 4 different static cameras, like a dome or something like that, and that will cover that sector every time, you know, 24/7. It will stay looking on it and recording full resolution there. So even that you're moving around with the PTZ, we are not losing any information around this camera. And this multi-sensor basically do this. It will combine. So I will put here, for example, let's assume that it's this way here, that we have 2 sensors and it's capturing here, and then this one is capturing here. So let's assume this one is getting this part and that is this part. The camera inside here, it will get a full picture. It will get a full picture. It will combine the 2 images in just one. And let's assume that we are talking about a 4 megapixel for each sensor. It really have the full 4 megapixel for this sector here, and then it will combine. So if you zoom in this area, it will not divide the resolution for all the area like we divide in the fisheye. Okay, and then we have next type of cameras. We have, I will put here a different thing here. Thermal cameras. These type of cameras are used in specific scenarios, specific environments. It's not cheap. It's an expensive camera, some regions, some countries have a restriction to import this type of camera, but it basically will detect the thermal signature of the target, and you'll be able to do like a perimeter protection or any other application. So for example, if you have a perimeter in an area that you have like a forest or too many trees around the fence, or a region that it's a very complex scenario that you cannot distinguish if it's a person or the environment of the scene, the thermal camera will be able to detect if it's a person shape in the middle of the trees, for example, or if it's too the area is too, or if it's a wider area that you cannot have IRs or light everywhere, the thermal will be able to detect the temperature in a good range. That will depend, of course, of the model. So in a specific scenarios, it will be a very good solution, but again, it's very expensive, and it's very focused for specific projects. And the last one, it's similar to the others here, but I will put as a different type, which is the explosion-proof cameras. The most common type of an explosion camera are bullets and PTZs. So, but it's not like a standard PTZ. It's a different shape of PTZ, as you know, all this structure will require the mechanism that will not trigger an explosion. So it's a different type of camera that again is specific for a scenario that will require this type of application. Okay, so these will be the cameras that will capture the video. And we'll have another component in this capture part, that is mountings and brackets. So mountings and brackets. We have the cameras. So for example, we have this camera here. We have this camera here, that we have these 3 holes here that you probably will install in a wall or in the ceiling, and that's okay, right? So you can just install here, and that's it. But not necessarily, because you have all this part of the cable that you need to protect. So if you're installing a brick wall, for example, and it's not like a drywall that you can pass through all this part of the cable and then install the camera. We have these mountings that you can put this cable there in this little box, and then install the camera on top of this mounting, and then the camera will be fixed, and then will have its own cable safe as well. We have different types of mountings. We have so we'll just put here like a standard mounting. We have a hole here to pass the cable, and we have several type of installation patterns to be able to handle more type of cameras. And then we have in the other side here that will be the surface, and then we have other holes here in the other side to install in their surface. Okay, so this is like a junction box. We have junction box, mountings. We have ceiling mount. So if it's like a drywall ceiling, that you can have like a hole here and install specific cameras that will be able to to show only the dome here in this part, and have the other part of the camera inside the ceiling, and we'll have some parts that will make it fixed there. We have, for PTZs, we have extenders to be able to have the camera next to the scene that it needs to protect. You know, if it's like some big supermarkets, you know, that we have a very high ceiling, you can have this type of you know, extenders and mountings. We have the pole mounting, so we have a pole here. Normally it's a mounting here with two parts that will fix in the mounting, and then we can install the camera. We have corner mountings, so in the corner it's you fix the structure first, and then it will have another part to place the camera. So again, it's have several type of mounting brackets and junction box to adapt the camera for what you need in your project. But one thing that is very important is to choose the correct adapter or mountings that your manufacturer recommend, because, for example, if it's an IP66 camera, IK10 anti-vandalism camera, you will not use any mounting or junction box, right? We have a very cheap ones made of plastic, so if you go with a hammer and try to destroy the camera, to destroy the bracket, and the camera normally is installed on top of this mounting, for example. So it will destroy the mounting, and the cable will be exposed, so the burglar can, you know, cut the cable and you will lose this camera. So it's very important to choose the correct one for your specific installation. Some of the installations will require specific junction box or mountings to be certified as an IP66 installation as well. All right, so we talk about the camera parts. Now let's talk about audio. So we have basically two ways to record audio, and let's just initially try to understand why we are recording audio. So depending on your project needs, we need to record audio to really register what is being discussed in the area. So if it's like a cashier or an area that will require you to record all the transaction, what is happening, etc. But of course, this needs to be legal in the country or in the region that we are applying this type of projects. But we have other type of needs as well. We have audio detections, audio analytics, that you can identify some type of noises in the captured audio and trigger some alarms. So for example, a gunshot detection. We have some cameras that can detect this type of specific noise. So when you have an embedded microphone, you'll be able to capture this type of noise and trigger an event to the monitoring system. We have crowd detection, that when it start to, the background noise start to be higher until a threshold, it will trigger an event. So we have different ways to use audio. It's not necessarily only to record conversations. So the first one is the embedded in the camera. So I will create here a camera and I'll put here this dot that will be the microphone. So I have here a camera that you guys will be able to see these three little dots here, that these three little dots is the microphone. So this camera has an embedded microphone, and you'll be able to stream with the video stream to the NVR the audio. So the embedded is one of the options. The second one is the camera put here just an external microphone. So we have a few cameras that we have the alarm input and output, but we have the audio input and output as well. And this type of applications, we can add external microphones that you can place anywhere in the scene, and it will record and will stream with the video stream of this camera. So that's very useful as well. And the third one is the external microphone connected directly to the NVR. In this type of installation, the audio line will go in parallel with the Ethernet cable or the coax cable, and it will record directly in the NVR. So some NVRs we have specific inputs that it will be able to record the audio with that channel that is associated with. So it's another way to capture the audio information. Okay, in the last part of the capture, let's talk about cables. So cables, we have Cat 5e, Cat 6. That will be the most used type of cables for IP or for coax with balloons. So what is balloons? Balloons is a device that will be able to use one of the pairs of the Ethernet cable and transmit the same information that we're transmitting in the coax cable. But normally we use, Ethernet cables for the IP cameras, and we have the coax cable. Coax cable for analog or high quality analog cameras. This high quality analog, we have different ways to call it, but it's basically cameras that will be able to have more quality using the coax cable, using the legacy installations, the analog installations. So you see now in the market cameras like 2, 4, or even 8 megapixel cameras via coax cable, and basically using the same connections that we had with the very old analog camera. So this is a very old analog camera, and then you see here the connection type. So this is the coax connection, and this will be the very old coax cable as well. This is the balloon. We have here the part that we will connect. We'll connect the pair of the Ethernet cable, and in this other part will be the one that we will connect in the camera or in the NVR, in the DVR, in the back of the DVR. So it will match here, and then you'll be able to install this way. Okay, so that's cover our capture part. So all devices that will capture the information from the scene, the video, the audio, and will send this to the NVR or not. So we will see now in the next part. Okay, so let's start the recording concept. So previously we saw the capture devices, and now we will see how we can record this information, how we can retain this information, this data from the scenes. Because it don't make any sense to capture and not record, right? It's a very low number of projects that we really will only see live and not record. Of course, for the very small applications, like for home applications, if you want only to be able to see the backyard or the front door, if it's someone there, but you don't want to record anything, that's fine. But normally for a video surveillance system, it's basically all projects will require you to retain this data for analysis or just to have it if you need to do an investigation. Okay, so in the recording part, we have basically 3 ways that we can record. We have something called edge recording. These type of recordings are normally used in home installations where we have a standalone Wi-Fi camera recording there on its own, and sometimes pushing clips to the cloud, motion detection clips. But normally it's if you're like having a very basic and a cheap camera, it will record only in this SD card that is inside the camera, and you'll be able to retrieve some of the recordings in your mobile phone. So this is one of the uses of edge recording. The second use is a failover mechanism from the camera. So for enterprise systems or even on a high SMB, small and medium market business, we have some cameras that will be able to detect if you have a network issue with the NVR, and when it's detected, the camera will start to record this in the same mode that is set in the NVR. We will see in the next part, but it will be able to detect this connection loss, and it will start to record in the SD card. When the connection is established again, so let's assume a switch in the middle had an issue. So the camera started recording locally in the SD card, and when the connection is established again, the issue is fixed, the camera will send these clips through the network to the NVR. The NVR will incorporate on its timeline, and it looks like nothing happened on this event. So that's very useful, but not all cameras have this feature. Okay, the other type of recording is using NVRs or DVRs. So this is the most traditional way to record. We'll see the different types. So the camera connection go to this device here, and then we have different types of NVRs and DVRs that will be able to record the video. And then we have the cloud. And this can be combined. The cloud not necessarily is an independent solution in this scenario, but can be a specific type. We have cameras that records directly to the cloud, cameras that use the SD card to record and the continuous recording and send only the motion clips to the cloud. We have NVRs that can send motion detection to the cloud, motion detection clips to the cloud, or we have like a mix, but it will be a different type of solution because it's not locally and need to be sent to the cloud, all the images. Okay, so let's now expand this part of NVRs and DVRs and talk about this. So the first type, the most old one, the legacy stuff, is the DVRs. So it's digital video recorder. And this type of DVRs, we have all the camera cables going physically to the NVR, to the DVR, to the back of the NVR. So we have the ports like this one. This is an encoder, but basically that's the same port. So all the camera cables needs to go to its cabinet and plug in the DVR. So it's analog, fully analog, and now the cables going here, and it will start record inside this DVR. We will have the hard drives, and then that's it. That's the solution. So DVRs, we have hybrid DVRs as well. Hybrid DVRs basically is the same of a DVR, but it will be able to handle IP cameras. So we will still have, you know, the coax inputs, but you'll be able to handle IP cameras as well. So we have an Ethernet cable here, Ethernet port that will be able to connect to the network, and you can grab a few of IP cameras. Normally, a hybrid DVR, it will vary from manufacturer to manufacturer, but normally they support like half of the channels the NVR has. So if you know, if it's 16 DVR, it will be able to handle 8 IP cameras, because normally IP cameras will be in a higher resolution than the analog cameras, of course. And hybrid DVRs are normally supporting higher resolutions in the coax cable as well. So the high quality analog or HD analog will be able to be used in these hybrid DVRs. Then we'll have the eNVRs. So the embedded NVRs are basically boxes here that you have the operational system, that you have the firmware, the software that will do everything in the recording part and the other tasks as well, and we'll be able to get the IP cameras data and record this video stream. Depending on the embedded NVR, we can have the PoE ports in the back of the NVR, so simulating like a DVR that you have to connect all the cameras directly. So like this one here, let me show. So for example, this one, so we have 16 PoE ports here, a port that is it's a WAN port that it can connect to the external, and a LAN to local. So here in this case we can connect a camera in each port here, and it will be assigned to a channel, and or you can connect, for example, a camera switch, so all the cameras connected in a switch, and just plug one Ethernet cable here that it will be able to record all the cameras. So this is an embedded NVR. We have everything here on this box. You just need to turn on in the power, plug the cameras, do the initial configuration. That's it. Everything is here. And if you need to monitor or do the playback and etc., it's all here in just one box. Normally, these type of devices are very reliable because are designed to do only this task, and normally are like a Linux-based devices. And well, I think that's all the major comments on this type of eNVRs. And we have NVRs that can be software or like a server type. So these type of NVRs, so this is like this embedded NVR. You can put it in a hack. It can be, we have hack mounts for this type of NVRs, but normally it's not designed for enterprise installations and etc. But we have for enterprise segment, we have NVRs that are really a servers, like from HP, or really dedicated servers to run a specific recording software. Can be from any manufacturer. We have several manufacturers that has software NVRs, and then we install on the server and it will run on the server. So normally the servers are Windows based, Windows Server. It will depend on each solution, and you can cascade this. You can have like child parent structure, and it's more like an expensive solution but more reliable for an enterprise project. Okay, so let's talk about storage modes. Okay, so we use specific hard drives for video surveillance. We can use standard hard drives, but they do have a reduced lifetime. So this one here is like a Seagate video hard drive, so this will be able to handle, this is like, let me see here, like a 2 terabyte hard drive. We can have several different type of sizes, and but the hard drive class is very important for your project. So one important thing is some installers use like an SSD hard drive, which is totally a no-go for this type of installations, because it will be continuously recording, deleting, and this type of operation is not the optimal operation for an SSD like hard drive. Of course, if it can be used, if it's like a server class only, it can be used for the operational system and for the recording software itself being installed on this hard drive. But the video recording, the content that we'll be able to be recording and deleting every time, this needs to be in a specific hard drives. We have purple classes, and we have specific classes. I'll put here in the screen, so you can reference as the best optimal hard drives for the video surveillance. Okay, so let's talk about the storage types. So we have the FIFO, or the recycle. What this type of recording do? So we have here, let's assume that here is the hard drive size. So it will start to record here, and it start to fill all the NVR hard drive, and then when it reaches here all its size, it will start to, so here's the input. So here we start to delete the first images or the oldest information in this hard drive, and then it will start to record this again, and it will do this in a cycle mode. So being the cycle mode forever until you change any parameter. Okay, so this is the first in, first out, and a recycle type of recording. We have another one that it's the retention time. So the retention, so we have here the NVR size, and then you define a retention. The most common retention time in the installations is 30 days. So it will keep 30 days of recording, and even if your hard drive have more space to record more days, it will start to delete the old files and only keep the retention time that is defined. But one thing that is important that a few installers forget, that Defining only this information will not ensure that you really have this retention time, because retention time is defined by the video stream. The video stream is the combination, the sum of all the bitrates of all the channels. We will be able to calculate how much storage you need, like for example for 1 day and for 1 week and for 1 month, and then have this information here. So let's assume your calculation based on the average movement in the scenes that you have in the installation, you require 7 terabytes of hard drive, and you buy like 10 terabytes, right? So 7 will be a little bit here, okay? When you define the retention time 30 days and you calculate, okay, it will be about 7 terabytes these 30 days, but you have a fluctuation on this calculation. Okay, sometimes you can have like a fog or rainy day that you have more noise in the image, more movement, more, it's like a peak. So you can have like a fluctuation between having a few months 6 terabytes or sometimes 8, and fluctuate between these 7 and the 6 and 8. And this is good because you still have a buffer here that you will be able to be sure that you will still have your 30 days here. Okay, so in this way you will record always the 30 days and then start to delete the old ones, and always keeping a safety buffer. And this is good to really have a safety space, but it's good for the hard drive health as well, to not fill 100% of the hard drive. So it's a good option. And the last one is the stop mode. The stop mode is we still have this option in a few embedded NVRs, and basically what it does, it is basically stop recording when it fills the hard drive. It's used in very specific installations, in very specific applications that you want to record, and you don't want to lose anything prior someone evaluate if needs to export something, etc. So it's not like often used, but it's a mode that we have. So it will start, and then when we fill the hard drive, it will stop the recording. And when it stops, it can raise a flag, it can raise an event, and then the monitoring team will do the actions needed on this NVR. These were the storage modes that we have. We have now a few recording types. That thing, recording types. So, okay, recording types. The most common used one is continuously. So this is our 24/7. This means that once it's connected, it will record all the time non-stop until it's recycled. So you guys know the process. So this is a mode. Another mode is by event. And when we say event, we can explode here in lots of type of events. We have motion detection. So the standard motion detection will identify a group of pixels changing from the scene, from the static scene that it's pre-analyzed from the camera. So when it detects this group of pixels moving around the scene, it will raise an event, and then with this event you can trigger a recording. And you can trigger a recording in a specific amount of seconds or minutes, depending on your model, recorder model. This type of event was used for several years, But the problem with the motion detection, the standard motion detection, is the number of false alarms, false events, because it can be triggered by a tree moving its leaves, the shadows, shadows moving around the scene, light changes, have like a sunny day and a cloud appears and to be a little bit darker can trigger the motion. So we have new ways to detect motion type of events, and it's the smart motion detection. So this type of event, it's powered by AI normally, and it will detect person, car, or any other object. You can have a motion detection detecting other type of objects as well, but normally we use person and cars for the general monitoring systems. So if a person enters in the scene, if a person leaves the scene, if a car passes by the like a street in a specific time of the day or in the night, it will trigger a recording as well. At the temper, this temper event is if a camera is, so if someone put like a flashlight to the camera or try to spray something, block the image. So this analytic can trigger a recording, of course, not in the camera that is suffering the attack, but you can have other cameras that are pointing. So let's assume we have this camera here, and then we have this camera here, that is not in the schedule to record this time. But if some burglar goes here and block the view of this camera, you can trigger this camera to start recording, and capture who is doing this. So it's another type of event. We have other ones like intrusion detection. You can have the scene here and you can draw a line or a shape. So if someone pass through this shape or pass through this line, it will trigger as a intrusion detection. It can call as a fence alarm as well, depending on the manufacturer. You can have different ways to call this type of event. We have people counting events that can be a trigger for recording as well. So cameras pointing straight down through an entrance of a store or any other area, and can count heads basically, or other cameras that can count people passing through a line as well. So this type of events can be used to trigger a recording. Cars, let's try to draw here, car. So we can have like a speed detection on illegal U-turn, on illegal parking. We have different type of events related to cars as well that can be triggering a recording. Okay, and the last part is alarm. We saw this in the other class. We have the alarms in the cameras. We have the alarms in the NVRs. So we have the alarms input and outputs. So in this case, it will be using the alarm inputs on the devices. So or in the cameras or in the recorder. And then this can trigger a recording. So let's assume a very low type of integration, low level type of integration with an intrusion system, an intrusion panel. If the intrusion panel is alarmed, it can close a contact, and this contact is connected to the NVR input 1, for example, and then it will start to record a specific region. So if close another input, it will start to record other region from on the installation. So we can do this type of triggers to start the recording. Okay, so let's now talk about the storage type, or the storage types by market, basically. So here for SMB, small and medium business, we have the standard way that we will record is in the NVR itself. So we have 1, 2, 4, 8 SATA port, SATA base here inside the NVR itself. So you plug the NVRs inside and it will record locally here in the NVR. This is one of the solutions that we have for recording, and for SMB we have some kind of SATA expanders that we have basically several slots, several bays here of hard drives, and then we connect through SATA, and this will expand the numbers of hard drives in this NVR, and the NVR will be able to record on these hard drives as well. So this is normally the solution for storage for an SMB class installation. I will not talk about like home installations when we're talking about independent cameras connected, so Wi-Fi cameras. We know that basically it's we are talking about cameras with edge recording, with cameras recording in the SD cards and pushing clips to the cloud. But here we are talking about a standard installation for professional installation that will be able to store here more content with this type of expanders. Okay, and in the enterprise market, we have we still have embedded NVRs for enterprise market, but it is kind of different type of NVRs, right? We have like a dual power supply, we have dual NIC that will be able to network interface card. We have like to be able to do like the load balance between them, and we can have the hot swap and RAID. So this type of NVRs, we have a few slots here that you can like swap the hard drives on the fly, so the recorder is working and for some reason one of the hard drives is failed. You know, it's raising an alarm that this hard drive is not working. So with RAID, I will not go too deep in the RAID, we will discuss this in another class, but this will ensure that the recording content will not be lost if one of the NVR hard drive fails. Not just one, but can be two, depending on the level, the number of you have, right? 0, 1, 2, we have different numbers that it will be able to tell you how much is protected against this type of situation. So with hot swap and RAID, we can swap the hard drives with a new one, working one, and the other hard drives will regenerate the information that was present in that faulty hard drive, and then we'll have your system back again, working as before. Okay, so this is the mid-enterprise type of solutions. But after this hot swap and RAID, we will have the in the most used architecture, we have here the servers. Okay, so we have the NVRs here, the servers, and normally the recording is not happening inside the servers. The servers will have the operational system hard drive to run its software, but it will not store in this device here physically. We have other type of devices that are called NAS. That is a network storage device. That is a network storage device that will be available here to the NVR to record the streams. Okay, so in this part we saw an overview about the recording part, how important it is to the system and what are the different type of recording mechanisms and components on this part of the video system. So let's talk now about monitoring. So this is an important component for the system, for the video system. Not all installations will use an active monitoring. Some installations will have the recording happening in the background there in a room, and if something happens, if we have like a robbery or if we need to investigate something, they will go to this room and do the investigation. But normally we will have an operation room or someone seeing the images, checking the live feed from these cameras and acting if needed. Okay, so this will be our monitoring part. The first one here is the local. The local monitoring directly in the embedded NVR. So the embedded NVRs can handle basically all operation. So it can handle the image capture, the recording, the playback, the monitoring, everything. So here we have USB ports that we can connect a keyboard and a mouse. We have the HDMI and VGA to connect the monitor and the cameras, of course. And then you can do all the operation, but it's limited because the NVR needs to have a powerful hardware to do all its operation and decode the video. So it will be able to decode locally in a monitor, but we'll face a few limitations depending if it's on the NVR class, if it will be able to decode at a specific resolution, or if it will be to dewarp on a fisheye camera. We have several different type of limitations in this type of solution. So this is local. Software client. So this one here, it's a software client. So we are talking about a computer We're talking about the monitoring happening in a computer. So this computer is connected through this NVR, and you're seeing the image here in this screen. You're operating here the PTZ and doing all the monitoring operation in this computer. So in small installations like small stores and etc., we can have like a security room. Then we can have a security guard there with one computer, 2 monitors or something like that. It will be able to handle more tasks at the same time. We can connect more than the one screen independently, and it will be able to decode more channels at the same time. So it's a better solution than the local one, but still have a few limitations. And we have the third one. That's the video wall. So the video wall basically combine this soft client here solution in a bigger scale. So let's assume that this is a very big room, and these little squares here are televisions grouped by a decoder device. It's a hardware device that you'll be able to plug every television here, for example, and in this decoder, and a software client that support a video wall system will be able to control it, this decoder, and show the information here in the screen. So you can assume that we can have multiple people here on on each one on its desk working on their sites or locations and checking, etc. So here can be displayed the most critical installations live for the supervisor, or if it's happening an event, a critical event, someone can put here in this screen and have more people looking and helping on the situation. So the video wall will help the entire team to act as a group, or basically to show critical and important feeds that needs to be constantly monitored. So this will vary depending on how each monitoring company do their work, but it's a type of monitoring that we can have as well. And as we saw before, that we can have the recording being done by cloud, we can have the monitoring as well doing by cloud. So let's assume that you have small NVRs or cameras connected directly to the cloud here, and cameras. You can have a computer here connected to via internet browser and consuming this feed as well. So it can be done depending on the size of the installation. This can work very well. And when I'm saying software client, I forgot here to put mobile devices. So mobile devices, so the application, so mobile application, iPad or tablets, etc., will be able to use this type of monitoring as well. Okay, so the monitoring task is something that we will do in this video installation, and this will require to connect to the NVR to monitor, right? So let's talk about connectivity. What are the types that we can connect? How can we connect to these NVRs from these clients here, software clients or clouds and etc.? The first one, it's an IP or host name. So through the network, you can connect. Let's assume here it's in the same installation. We can connect here directly to the NVR's IP. You add in the software and then we start to browse it. It's very powerful and has a very good performance because it's locally and you're connecting directly to the NVR without anyone in the middle. After that, we have the DNS. So what is the DNS? The DNS, in a very basic way, here's the NVR, here's the router, here's the internet, here's the other router, and here's the computer doing the monitoring. So, and here it's a cellular tower and the mobile phone. So when you connect via IP and a host name, it's easy for LAN, for local area networks. But when we're talking about connecting NVRs remotely from other installations, you have this situation here. So this NVR is an installation that has a public IP, and this public IP can change or may vary, after a specific amount of time. And if you add this external IP, after a while it will fail to connect because it will change. So this DNS, basically we have a server here, the DNS server, that this NVR needs to have this feature, of course, that you configure here in the NVR. So we have different type of the DNS providers. So once we set an account and the provider here, this NVR will tell this DNS server, hey, my external IP is this one, and this server will store this information. And when you try to connect to this NVR, you not use the IP, you use a custom host name that you will create here in the server, and this host name will be translated to the latest external IP on that installation, and this will make this work as you are connecting directly. Okay, and then we'll have the P2P. So P2P is very similar to the DNS, but it's a more it's similar, but it's easier than the DNS because you don't have to set up basically anything. We need to enable here in the NVR, and then you need to basically scan a QR code in the mobile device, or include like a P2P ID in the software, and it will automatically connect. So it looks like magic, but it has its own way to do this process. We have a P2P server here as well to restore how this NVR is connecting through the internet and giving this route to the clients to this NVR. I will not go deep in this content right now, but you need to know that it's an option, and actually this is the most used one when we talk about this type of NVRs, the embedded NVRs. The enterprise ones, normally we don't have this type of connectivity, but we have this, like this QR code you can scan in the mobile application, and it will automatically add this NVR. Okay. One thing that is important for this type of monitoring, we have a few accessories that that we didn't talk about yet. So we have the KBDs or joystick. So basically, this type of devices helps a lot the monitoring team to control PTZs, control cameras, control the camera split mode. So here you can see this like a keyboard that you can control PTZ, you can do some functions, you can have a shortcut for playback, live view, a specific camera, so you can type the camera ID. And this type of keyboards that are meant to video system is very used on this monitoring environment, because it's very quick to operate instead of a standard keyboard, a PC keyboard. Okay. Now let's talk about a few challenges for monitoring. First one is rendering, and this we need to always be on top of this topic, because it's something that will really show issues, or it will really it will really impact the monitoring operation. The rendering action is to decode the video file to the image again. And as we are having cameras with more resolution, more FPS, more bit rate, we need more powerful equipment to do this process. So if you need to decode several cameras at the same time, we are talking about a lot of processing power. And the old softwares, the old monitoring softwares, used first only the CPU, only the processor to do this task. And we had a limitation on this type of use. And then we had newer softwares that start to support the GPU. So the using the graphic cards to actually do the graphical processing task for the computer, for the software. So then we can increase a lot the number of cameras, the resolutions, FPS, the bitrate in the end, being decoded at the same time. So we can imagine like a big monitoring room with a video wall with several cameras. We are talking about more and more equipments to be able to handle this rendering part. So for monitoring, this is a very important topic. So if you don't have the gears with the correct spec for that, we start to have issues, freezing issues, crashing issues of the software, because we will not be able to handle this workload. And bandwidth. Bandwidth local and in the monitoring room as well. So when I say local, I mean, imagine a customer that has several different locations in the country and they are monitoring in just one location. So depending on the location of the store, you will not have a good internet connectivity. And this can impact a lot on the monitoring side, but because if you have a bottleneck in the uplink in the location, you reduce the information that we'll be able to share from this location. So we'll not be able to render all the cameras, or if you have an issue there, so we need to plan accordingly to your specific locations, to each site, to check the internet connectivity quality, if it's enough for your solution, because normally they will share this internet connectivity with the security video system, with other systems as well, with the ERP, with the other solutions this company has. So it's a critical point locally. And in the monitoring room as well, because in the end we are handling a lot of traffic in this room, in this monitoring room. And we need to have a very good network structure to handle all this data traffic in the room as well. Central monitoring station. So this is a type of companies that do this type of work of monitoring that we are talking about. I will just cover the basic task they do in this process, but I will not cover all the process. I will just cover two topics that they do when they are monitoring a client, or this central monitoring station can be for just one customer as well, but normally it's they will have more than one customer in this type of business. So the first action, so they will do an active monitoring depending of the contract, depending on the customer type or the way they work, but normally they will receive alarms. The alarms that we saw that trigger recordings, these alarms can be sent to the monitoring viewer software, and they can trigger pop-ups or other actions in the monitoring room. So the first thing that we will do, they will check the alarms and check if these are like a real alarm, it's not a false alarm, and they will need to treat this alarm, right? So second one here is the ACK. So they will do an acknowledge, and it will include the information of the actions they are doing in this type of situation, because this will be in the reports they will export to the customer or to their supervisors. And then the third one, they will actually do the action. It will call the police, will call the security guard in the area, and etc., etc. So of course this is a very generic list of the procedure they will do on this type of situation, but the idea here is just to give you overall of normally what's happening when an alarm comes in the monitoring room. Okay, so they will check if it's a real alarm. Normally they will open a few camera streams to check if it's not like some animal that it's there, it's triggering this alarm. So if it's really let's assume that's a false alarm, they will acknowledge this alarm to leave the critical area they have, and include some comments there, oh, it's an animal, and then this will be archived to for reports. Or if it's really a burglar, it's happening an event, they will acknowledge to leave that specific area, and it will put the action that they will need to do on this type of event. It's called the police or called the local staff, or etc. So these normally are the steps that they would do in this type of situation. And talking about CMS, we have different type of monitorings, right? Monitoring solutions. So we have here, let's assume here the NVR with the cameras, and then we have the internet here, and here the monitoring room with a video wall. Here, and the staff here. Okay, so we can have this location being connected remotely and monitored here by this central monitoring station, or depending on the size of the customer. So let's assume that it's like a bank, a very important and big bank. They will operate in several locations, 7 countries in several regions. So this normally doesn't work as well. So we have a structure that is called parent and child. So let's assume that we have this installation here, and this installation here, and this installation here. It's a region. So let's assume it's America's region. So this one will be will have a monitoring room. These other ones, it will be for Europe, and this will for Asia, and etc., etc., etc. So we have here each one with its monitoring room with its own staff and etc. And we can have a centralized parent structure that will connect to each one of these central monitoring stations and receive the alarms as well. So this is like a very high enterprise class system, but just for you to understand that this is an option as well. And this and on these solutions we have an option to share connection with police departments. For example, some countries this is like a normal procedure. So if it's a high crime area, they require for homeowners or the store owners to share a connection with their NVRs that it's pointing, cameras pointing to the perimeter, to help the police to monitor the area as well. It will vary between each region, each country, regulations and the way they do their work, but it's an option. It's possible as well. Okay, so in this overview, we saw all the components and how it looks like a monitoring task, a monitoring operation on the video surveillance. Let's jump to our last part, which is playback. So playback, it's basically when you have every information recorded, when we have the staff checking the live feed, etc. We have the recording, you have everything running as normal, and then we have a situation, you have an event, you have an alarm, you have a break-in, you have an incident or an accident that we need to review and investigate. This is the time that you do the playback and on the investigation process, right? So okay, so investigation and forensic, it's one of the reasons that we will jump in this feature in the NVR. Again, the embedded NVRs, we can do this locally on its output, video output. We will be able to do this, but we can do in the software part as well. And for cameras, even for home installations that we have only standalone cameras will have this feature as well, the playback to review the footage. So in this investigation process, in the forensic process, we are trying to probably identify if we can identify a license plate, identify a face of a person, and this will require us to go through the images and identify sometimes when the issue happens. So let's assume that you not have an active monitoring and you leave from your store, after hours. So like, let's assume 8 p.m. you close your store, go home, and then when we return, you have, the window, you have a broken window, and you want to check the images, right? To see when happened and if you can detect who did this. So the first thing is to check when this happened. And when we go through the NVRs, or actually the old DVRs, we see here like the timeline, we have the channels, etc. Here's the live view. Normally in the old solutions, we had to watch all the content, all the recording to check when this happened. So we could do like a 2x or 3x speed, but we had to check all the time, or try to click in some parts of the timeline to isolate a group of hours or minutes there. But it was a very painful process. Now, after the like motion detection, etc. events, we had the smart search that we could search for vectors, search for moving vectors from the pixels, and then we can isolate a little bit when we had like some movements and etc. But let's assume if it's a camera, it's an outdoor camera pointing to the front of your store, and you have the movements from the people in the street, in the cars, and etc. It will be very hard to isolate what is the movement that generated the break-in in your store, and the movements, the normal movements in the scene. So then, when we use the analytics, the smart motion detection, the intrusion detection, to help us isolate all the content that we have stored in actually events that you can easily and quickly find. So let's assume if instead of checking the timeline for the events, you can check a list. Okay, so give me the camera 1 all the intrusion events. It will give a list of 5 or 3 of person that crossed an area that should not cross. And then you'll be able to quickly go to the specific part that you need in your footage. Okay, so this is one part of the playback process, to find when happened in the timeline. But after you found when happened, normally it's not isolated only one camera, right? If it's a considerable, if it's not too small area, you have more than one camera. You normally have 3, 4, 8, 16 cameras in the site. And then this person came from the front area and goes to the storage and goes to other places and etc. and do a lot of stuff inside your store. And probably at some point you'll be able to detect this person's face in one of the cameras. But how you do this if you don't have a way to follow this person normally, right? If you're using independent camera systems, you probably can't do this. We need to close one camera view, go to the other camera, do the playback, start on the time that this person disappeared from this camera, and then check in this camera and do these to other cameras. To avoid all this trouble, we have the sync playback. That it will basically have, let's assume here, a screen that you have all your cameras, and then you click here like a button to synchronize, and you have all the cameras running or playing at the same time. That if you search here for a specific event time, this time will be synced with all their cameras. So, okay, this person is leaving here, this camera part, and it will show on this other camera. So it will show here, and then it will leave this area and it show here. So you don't need to log in or to enter in different cameras to follow this person in your installation. Okay, so this is a feature that today basically all the NVRs will have available for you to do this investigation. Okay, and basically that's the process of playback. After you identify the person, hopefully you identify the person, you can export a picture. You can export a picture. For embedded NVRs, we can connect a USB stick, it will save, and that's it. You can use this picture to send to the police, etc. Or you can export a video clip. Let's assume you can have a full video clip that you want to export. You can do this and with the same USB stick. But this video export normally requires special things such as watermark and digital signature. Because these type of elements in the exported video will ensure that this video was not tampered and can be used in court or in any legal process. So depending on the NVR or in the solution or in the manufacturer, you have these options that will ensure that this clip was not tampered, so we don't have any missing frames, anyone that tried to cut specific parts of this video to try to show another version of their story. So this action here to export with this digital signature or watermark or whatever the way they call, the manufacturer call this feature, can be used as proof, of course depending on the country, on legal processes. And this concludes our masterclass today. Hope you could have a good understanding about the key components of the video surveillance system. I know that several of these key components I just gave a high level view of how it works, but we will explore this more in other classes. But with these components that we saw today, you now can understand better what are the types of devices that we use, how can we use, how it works, all the process and all things, capturing the scene, recording, monitoring and exporting, and working with the video surveillance systems. Hope you enjoyed, and I see you in the next class.